Hello and good morning everyone. Welcome to Group 2's group project about the application of numerical mathematics in earthwork volume estimation. This project is brought to you by Yoon T, Kevin Chai, Darren Daniel, Tae Heng, Lee Ji, and myself, Ahmed Muhammad. To start off the project, we're going into the introduction, including the background, problem statement, and the objective. To begin with the background, numerical approaches used to rely on hand interpolation formulas and data from massive printed tables before the advent of contemporary computers. The numerical perspective may be traced all the way back to the first mathematical publication. Numerical analysis is a mathematical analysis technique that employs numerical approximation to produce precise findings for some problems that are difficult to solve otherwise. As for the problem statement, we are given a total area of 1200 meters square of land that is going to be developed. As shown in figure 1 below, the cross-section of the existing ground level of the proposed site and the length of the land is divided into 15 intervals. The proposed formation level is 3 meters high. As civil engineers, we are required to calculate the volume of soil that will be removed and estimate the number of truckloads to remove the soil if the hauling capacity per truck is 10 meters cubed, using Simpson's rules to solve this problem. The objective of this report is to show the applications of numerical methods on modern-day issues in every possible way and how they are utilized. New numerical solutions and their new applications make significant advances in adjacent areas. For example, parallel computing greatly improves the accuracy of direct numerical stimulation of turbulence to capture undiscovered flow structures. Numerical solutions are becoming more and more important, and the latest developments are worth investigating. As shown here, we have created a filler table giving the facts, the ideas, the learning issues, and the actions that are supposed to be taken to approach these issues. And that's going to be it for my part. Now I'll pass on to my groupmate Lee for the next part. Thank you for listening.
Good day, this is Lee Zijing presenting the part of literature review. So for the first case study in the earthwork volume determination, the project area is 81 feet by 117 feet. It involved the contour method, triangular irregular network method, and grid method. So in the initial result, the contour method obtained great difference in volume determination compared with the thin and grid method. However, with the improved contour formula, it achieved the acceptable tiny difference in volume compared with the thin and grid method. For the second case study, it involved the grid method and the triangular irregular network thin method. The type of the terrain involved is uneven and flat terrain. In the uneven terrain, the final calculation result of the thin approach is more accurate than the traditional square grid method. However, both methods obtain a similar result for flat topography. This is all about my part. Thank you so much.
My name is Sundipo, and now I will present the methodology. Step 1 is determine the weight of the land. The area and the length are given, and the next step is determine the value of existing level soil. And step 3 is determine the volume of formations level soil. And step 4 is determine the volume of removed soil. And the last step is determine the number of required track roads. The capacity of track roads is given. Next, the formula we use is Simpson's 1/3 rules. And the formula is h divided by 3 times FO plus Fn plus 4 times F1 plus 2 times F1. And h means the length of interval, FO means the first value of height of area for left, interval A, Fn means the last value of height of area for right, interval B. The first Fi means the sum of value of parabolas with attached by the odd number segment. The second Fi means the sum of value of parabolas with attached by the even number segment. That's all about our methodology. Thank you.
My name is Tae Heng. I will cover the part of calculation. From the problem statement, we can obtain some information. First, the total area of the land is 1,200 meters square, 15 meter intervals, formation level is 3 meter high, the capacity per truck is 10 meter cube, and the cut section of the land. So to obtain the volume of removed soil, we're using the volume existing level minus the volume of formation level. So we can obtain the removed soil. Okay, from the information, we know that the area of the land is 1200 meters square. So when we divide by the length 102 and 120, so we can obtain the width. The width is 10 meter. After we obtain the 10 meter width, we can calculate the volume by the Simpson's rule to calculate the area times with the width. So just substitute into the Simpson's rule formula. So we can obtain the volume of existing level is 7,560 meter cube. And same with the formation level, just substitute the information to the Simpson rule formula, and we can obtain the volume. Volume is 3,600 meter cube. So after minus, we can obtain the volume of removed soil is 3,960 meter cube. So for the last part, we need to calculate how many trucks are needed to remove the soil. We know that 10 meter cube, the capacity of the truck is 10 meter cube. So we just divide it, 3,960 divided by 10, so we obtain 396. Therefore, 396 number of trucks are required to remove a total volume of 3,960 meter cube of soil from existing level to formation level. That's all for me. Thank you.
Hello, good day. My name is Dedan, and today I'm going to present about discussion. So, for our project, contour method is usually used in a large-scale project, so it requires more time to execute it. So, for width method is slow and also require more time to perform it. So, TIN, which is triangular irregular network method, requires software and skill to execute it. So, for TIN method, you can see that it achieve relative accuracy of 0.8%. While width method achieved 3.16%. So the lower the percentage, the more accurate. So for TIN method is more accurate than width method for uneven surface region. But for flat surface, both methods obtain the same result. So Simpson rule is selected for our project as the method to solve our problem. And that's it. Thank you.
My name is Kevin Chai Chi-Sian, and I'll start presenting conclusion. The main function of Simpson rule is land surveying. It is used to compute volume and area. Another function is to compute catchment area, drainage area, cross-section of rivers and channels. The advantage of Simpson rule is give better approximation, more efficient and more accurate compared to other numerical methods, such as trapezoidal rule. It has a proportionally lower error. For the limitation, there are some differences compared to actual integral. It is impossible to get precise answers in terms of fundamental constants. It will fail to give accurate results if a function is highly oscillatory or doesn't have derivatives at some points. That's all from us. Thank you.